Hi, this is Leetcode question course schedule. In this example, number of courses equal 7. We will use topological sort algorithm to solve this question. And to do that, the first thing to do is to build a graph from the given array of prerequisites. And to do that, we start from the first element. So we should take course 0 before taking course 1. So there is an edge, direct edge from 0 to 1, and notice the direction of the edge. That means before taking course 1 you should take course 0, and you need to take course 0 before taking course 2, and from 4 to 1, 4 to 3, 3 to 5, and 2 to 6. So this is the shape of the graph, and the representation in adjacent list here will be G. 0 has neighbors 1 and 2. 1 has neighbor empty. 2 has 6. 3 is connected to 5. 4 is connected to 3 and 1. 5 is not connected to any nodes. 6 is empty. Also, we need to calculate the n degree. N degree is the number of edges going into the nodes. So for 0 there is no edge going into the node, so we put 0. For 1 there are 2 edges, this one and this one, so there are 2 edges. 2 has only 1 edge. 3 it has 1 edge, because we count only the edges that go into the node. 4 has 0. 5 has 1 edge. 6 has only 1 edge going into the node. So in this loop we calculated the adjacent list for the graph and the n degree for every node. Now we have this queue, and initially we'll push into the queue the courses that has 0 n degree. So we have 0 and 4 of the value 0, so we push 0 and 4. So always we will take the course that doesn't need, or it has 0 n degree, so we take 0 from the queue. Now, because we are taking this course, we are going to remove the edges, and by removing the edges we mean to update the n degree for all the nodes or all the neighbor of 0. So from the graph we get the neighbors of 0, 1 and 2, and we update the n degree from for these nodes by subtracting 1. So the neighbors of 0 are 1, so we subtract 1 from the n degree. 2 minus 1 is 1. This is what we are doing here. And also node 2, the end degree is 1 minus 1 0. Now because the end degree becomes 0 after the subtraction, now this is this we can take this course, so we push it to the queue. Now we are done from this node. Next is node 4. Node 4, its neighbor 3 and 1. So from the graph, node 4 we have 1 and 3, and we are taking this course, so we popped it from the queue. And to take this course, we will remove these edges, and that means we need to update the end degree of the node 3. The node 3 in 1 minus 1 is 0, so because it's 0, we push it to the queue. So the queue now has node 3 because there is no longer any edge going into this node. The other neighbors of 4 is 1. 1 has end degree 1, so 1 minus 1 is 0. So because it's 0, we push also this into the queue. We are done with node 4. Next is node 2. Node 2 neighbors is 6. The end degree of 6 is 1. 1 minus 1 is 0. So because it's 0, we push it to the queue. And we are done with node 2, so we remove this edge. Next is node 3. Now node 3 has its neighbor 5, so because we are going to remove this edge, that means we need to update the end degree of the node 5. So 1 minus 1 is 0. Because it's 0, we push it to the queue. 5. We are done with the 3. Then 1. The end degree of 1 is 0, as you can see here, so we will not do anything. Then 6. The end degree of 6 is also 0 after we remove this edge, so 5. The end degree of 5 is also 0. And notice every node we pop from the queue, we update a counter called nodes. This is the counter, which was initially 0. And because we covered all the nodes in the number of courses equals 7, and here we have 0, 1, 2, and 3, and 4, and 5, and 6. So all the nodes were covered, and all the nodes pushed to the queue. So at the end, this counter will be equal to the number of courses, and if it's equal, we return true. So for this example, the answer is true because there is no cycle in this graph, and this algorithm can detect if there is a cycle by having this counter. So if this counter is at the end equal to the number of nodes, we will return true, otherwise we will return false. Let's take another example. So in this example, you can see there is a loop here. The end degree for this graph is for 0. There is 0 edges that going into 0, 1. There is only one edge, or there are 2 edges. So for 1, end degree is 2. For 2 there is one edge. For 3 there is one edge, and so this is the n degree. Now we push to the Q all the nodes that has n degrees equal to 0, and in this case node 0, and we iterate until this Q is empty. So the Q has value 0, we pop from the Q value 0. Now we will take this course, and to do that we remove all the edges that going out from this node, and we update its neighbors. In this case its neighbor is the node 1. So node 1, the n degree is 2 minus 1 is 1. Now after this step, the counter nodes become 1. So it was initially 0, and we handled one node, so nodes plus plus will be 1. And after we subtracted 1 from this, we cannot push it to the Q, because we only push to the Q the courses that or the nodes that has 0 in degree, and the Q now is empty, and we break this loop. Now nodes equal 1 and the number of courses equal 4. They are not equal, and in this case we return false.